Hey, my fabulous chemistry minions. There we go, new intro. Video 10, most important elements. Important might be the wrong word. We're going to go with the most common, anyways, by name and symbol. We'll learn some rules about these kind of things. So, some of the very most common elements you will encounter are pretty much the first 30. And there is a number in the bottom left hand corner that's big. You'll see in the key it's called the atomic number. That's how we name the or identify the different elements. Okay, first 30 really pretty common, along with some choice metals. Here we go. Lithium, Li. Notice that big 3. We're going to learn what all those numbers mean, but lithium is element number 3. Li equals lithium. Here we go. Fe is iron. Some choice metals for you to know. You're going to see iron quite a bit. Sodium, Na. Both of those are tricky to learn because their symbols and their words of the name of the element do not jive. I know iron for sure comes from its Latin root ferrous. Sodium, I'm not sure what its Latin root is, but I'm sure it starts with Na. Potassium, K, probably the same thing, Latin root. Cu is copper. We need to know that copper is Cu. Everybody's favorite gold. Au is gold. And Pb is lead. Those are some very common ones. Will there be others? Yes, there'll be some other non-metals we have to learn, but here's a few super important ones. Okay? Then, these diatomic 7. So this goes actually in that diatomic space. They always exist as paired molecules in nature, hence di. So if I have one atom of hydrogen, I will never find a single atom of hydrogen by itself. He is one of the diatomic 7. He will always be hooked to another hydrogen. So when we were doing those particle diagrams and we saw that you could have this molecule of an element, this is what we're talking about. There are specifically 7 of them and we need to memorize them. So let's get to them. So hydrogen is one of them. I'm going to go fast, you can go slow. Oxygen is one of them. And they're coming up in order for how I remember them. So HOF is the HOF. The BR is bromine. I is iodine, one of the hardest elements to learn because coming up is chlorine, and you'll see capital I and lowercase l are the exact same font on this thing. I apologize. New York State did it, not me. N is nitrogen. And here we go, Cl, chlorine, probably the single hardest element for you to identify just because you're going to think it's Ci, but it's Cl. That is the lowercase l. And it is also the capital I. I am very sorry about that. And this is how I remember them. Hofbrinkel, Hofbrincl, Hofbrinkel. And I just convinced myself that I could, I imagined anyways, that, Einstein named his dog Hofbrinkel. Like that was just how I did it. Hofbrinkel is one way you can remember the diatomic 7. When we get into the periodic table unit, I will have you color in the periodic table multiple times, identifying certain things. This will be one of them. Okay. There's one other way to remember this, and I didn't put it on there. So let me go back. There is one other way to do it, and it's called the 7H club. So on your periodic table, if you start at element 7, which is nitrogen, and you go across NOFClBri, that makes the number 7. If you highlighted it, you'd see that the shape is in the shape of a 7 and then H. So the 7H club is the other way to remember this. We will hammer that in periodic table to make sure we know it. There are only 2 liquids on the whole thing. One is a metal, one is a non-metal. Hg, mercury, is a liquid metal. We saw some videos of that in most of the classes trying to pick our element. Okay. And bromine is the liquid non-metal. Okay. Bromine. Most people think it's iodine. Iodine, because we've used iodine as liquid to, for an antiseptic, for a cut. That is not the truth. Iodine is actually a solid that is dissolved in alcohol. So that's tincture of iodine they're using and not, so it's actually a solid. So it's not just pure iodine. Okay. Then there are a number of gases. Hydrogen, of course, is a gas, which will be confusing because it's on the metal side. Okay. We're going to learn that. Helium is a gas. We have experience with that with birthday balloons. Nitrogen is a gas. We've heard of it in our atmosphere. Oxygen, of course, we know is a gas. We're breathing that in and out, or breathing that in every day. Fluorine is a gas, the single most reactive non-metal on the periodic table. Neon is a gas. You've heard of neon signs. It is a noble gas, and as a matter of fact, almost the rest of the noble gases will be involved after chlorine. Chlorine, Cl again, it comes up again. Chlorine's going to come up a lot this year. We got to get that memorized. And the rest of these are all noble gases 18, I believe. So we're going to do argon, krypton, xenon. So there's argon, he's a noble gas in group 18. Krypton, noble gas in 18. Xenon, noble gas in group 18. And, radon, poisonous gas in group 18. All noble gases. The name of that family is noble gases, so that helps us. Okay? And with that, we're a little bit more. Okay, so metals, non-metals. Ready? So non-metallic elements are going to be above and to the right of the staircase, not touching the staircase. And so let's see if I highlighted that. I probably did. So here's our periodic table. And this is what I'm talking about with the staircase. That is the staircase. And so above and to the right is here. These are my non-metals. Of course, not touching the staircase. That's going to be another special piece. Okay? So those guys are all non-metal. And then elements touching the staircase except for aluminum. You know aluminum is a metal. You've held it in your hand. So again, we got to identify our staircase. And then we're going to, everybody touching the staircase above and below, except for aluminum, is what we call a metalloid. Okay? So all those elements are some mixture of property of metals and non-metals. So we call them metalloids or semi-metals. And then the nice part about that is once we identify those, everything else is a metal. So below and to the left of the staircase, not touching the staircase, of course, is a metal. And we're going to do this all again in periodic table. You might see this part of the video repeated. I'm not going to lie because these animations took a while to make sure they were right. But so everything else is a metal. And this time I included aluminum because we've all held an aluminum can in our hand. It is a metal. I don't worry about the UUUs. They are man-made elements, and this periodic table and our periodic table are slightly different, as in this one's all filled in. Ours isn't even there. So we're not even going to worry about those guys. They don't stick around very long for us to play with them and understand their properties. Okay, and check it out. We're done. We just got a quick tour of the elements, and we will study them, of course, much more in depth as the year goes on.